Okay, so good evening, everybody. What can I say? An absolute huge full house. Well, you know what? You guys are in on the in-story. Most people here, I think we're all pretty familiar with what's going on with all the different light sources. So Azram and AMS acquired Azram a while back. And most of you know that Azram is essentially a lighting company for the last 110 years or something like that. So today we're going to talk about the Azram side and how we want to be the light source for all the different types of AR glasses. So we're going to give you a few ideas. I think we've got about 20 minutes, 5 minutes of Q&A. So I want to use this as a teaser, get some ideas going. We have a booth here. Tomorrow the whole schedule is me just standing in a booth, so let's talk. We have a bunch of FAEs locally in San Jose as well. So let's take this as the start and let's continue discussion moving forward. Sound like a plan? Oh, a few nods. Hey, excellent. Okay. Yeah, all right. So this is how we see life. So there's a line across here. You know, what's this all about? Enterprise. This word here is this machine makes money for whoever it is. So it's not about looking good. It's not about feeling. Not about user experience. It's about how can I shave 20% off of the field time or whatever. This is where we're all talking about the Facebook, Meta, whatever. You know, they're putting technology on people's faces. So that's a good thing. So this is where we're all sort of heading for, the next phone revolution or whatever. So this is how we see it. We're thinking about weight, size, and power efficiency. In other words, all-day wear, and that's sort of the holy grail. So how does the light system or the light source work in relation to that? Well, here's we work in it because, where is it? That comes up here. There's no one fits all solution. That's a bit backward. Basically, no one size fits all. You can have it all this way or this way. It doesn't really matter. You guys all know what this is. You can't have one without the other. 10 pounds of sand into a 5-pound bag. But you know what? We're going to try. So depending on where you want to look, I saw some presentations today where they're talking about combiner thickness of microns. But of course, with that you get practically zero FOV, et cetera, et cetera. So there's a lot of trade-offs. So when you come to our products, today there's some trade-offs. And we're going to go into them really quickly on the LEDs, into them quickly on the laser, and then open it up for Q&A. So today we have a 2-channel. So we have a single green, we have a red and a blue. You as a designer, you're going to get your big optics here and your tilted dichroics. And you can see all the different stuff here. We also have another way of doing it, which is a more compact. It's a single channel. It's red, green, blue. This is a 3-chip solution. And you can see putting this together in manufacturing is probably a bit more complex. And then there's this other way. We take the same chip and we put it into a mixing light guide. And this mixing light guide is a little bit different and not as sophisticated as dichroics and tilting filters, etc. But these are generically the ways to do mixing today. If I move this forward. And what's good and what's bad about them? Well, if you look at these types of way, it's quite good because with the dichroics, you end up, the étendue is basically a single chip. The étendue over here is you replicate it, so it's 3 times the size. But it's super small. It's lower cost. This here is quite big, but it's nice and bright. Again, this is showing you the trade-offs. You can't have everything. So depending on what you're looking for, performance is probably big if you're in enterprise. Small, lower cost is more into this prosumer style where you can get away with certain things. The only issue here is the homogeneity is a big issue. So a lot of times designers will put a film here, some sort of dichroic filter or a mixing filter. Again, it looks better. What it does, it kills the efficiency again. So again, a lot of different trade-offs. So that's what we're seeing today. Now, what can Azram do? Sorry, I keep on pressing the buttons here. What can Azram do? This is the product I was just showing you that's in most designs today. It's called the RGB O-Star. So you can see the size of it. 3 chips. 2.7 by 5. This is what we call the mosaic. So we got 4 chips in 3 by 2. So all of a sudden we're getting a lot smaller. Or we can make it into 6 chips. So you can have 2 greens in the middle here, or you can get rid of the red squelch if you put in reds, whatever. The biggest issue we see here, and this is the biggest advantage for designers, is we're getting rid of this glass window. So instead of a 0.4 from the chip to where you can put your optics, it's now very, very tight. It's essentially a coplanar technology. And it's I can't even really see it there. It's minimal comparative to where we had this before. And the overall z-axis is 0.7 to 0.8. But for those of you who, press this button here, now we can blah, 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 blah. One thing we can see, can we see it, is sitting up here. These are 750 micron chips. These are 500 micron chips. Again, if you take Rob from the left pocket, you have to give to the right pocket. We have 4 chips, but they're only 500. You have 3 chips, but they're 750. 750 in a bigger package, you can drive it more as well. It's a lot, the thermal coefficients are a lot better. So again, getting back to, we're trying to help and push the envelope, but a lot of times we get pushed back. Now, what does all that mean? So rather than showing this is an inventory for products, I want to give you an idea of how we're seeing this red, green, green, blue based AR display. So these are numbers that we've taken across a lot of different designs. Again, just to put it out there, we do not do designs. We are an enabler because we sell the light source, and we sell Lambertian light sources, and we also sell laser light sources. But if you're a designer, you don't really care about that. You care about every single part. So to give you an idea of how the losses stack up, if you have an electrical input of 1 watt into our product, on the outside, if this thing was not optimized, you're probably going to get in terms of nits, because that's what's the buzzword these days. I mean, some of you would know more about this than anyone, but most people say, hey, what's the nits output? So it's got to be over 300 to be indoor. It's got to be over 1,000 to be outdoor, or whatever. Everyone has a different sort of definition. But today, using our products, and if you have a generic sort of wouldn't say an optimized solution here. Start off with 1 watt of electrical power, you can get 350 nits. Now, if you do it a DLP from TI, you're dropping 20%. A nice, decent LCOS from one of 5 or 6 suppliers, you can get only a 10% drop. So you optimize all these areas, and there's customers out there today, and this is validated. They have these in presentations you can find on the internet, starting off with 1 watt, and they're ended up at 6,500 nits. To me, that's quite impressive. So that's just giving you an idea of where it is today with what we would call state-of-the-art LED technology. Now, where is LED technology? And getting back to the picture I had before, which had all the glasses. So we believe you've got to be less than 1 cc, cubic centimeter. We call it the magic sugar cube. You've got to be smaller than the sugar cube to get anywhere to where people want to buy these, consumer slash prosumer slash consumer glasses. Everything else around here is a bit of a mix-up. Why? Because some of these guys really want large field of view. So DLPs do a lot of better job, and then some of the old cheap LCOSs. So there's a bit of a mix here, and there's also depending on size. So this is a nice chart in terms of engine size versus field of view. So if we split it up that way, we now move into this area, the less than 1 cc. This here is one of our friends from the Laser Alliance, and you can see it here because it's their great work. Engine size is 1.7. These are the old TO cans. TO 38s. You can see this in our booth. We have a bunch of these old metal cans. You probably remember them from university days. And then this new RGB, this VegaLAS package. We basically take the same chips, we put them in a hermetically sealed device. And again, with all the work from people like ST, we can drop this down from 1.7 to 0.7. So that's a huge, big drop. And again, it's nothing from Azram's side. It's all in partnerships with these guys. And you saw the presenter who introduced me to Yussi, a guy from Displex, part of the Laser Alliance. So together we're working. This here is great. It needs to get even smaller. And we have roadmaps and things like that to show you moving forward. So what does Azram contribute? So clickety, clickety, click. So this is hermetically sealed. What we can do, if you're really mad into science, we can sell you the chips, but we started to maybe 2 or 3 times doing that, and within an hour we got phone calls saying, hey, why do the chips not work? And it's like, well, because they don't like the normal atmosphere. It needs to be hermetically sealed, which is no trivial matter, by the way, when you're doing SMT. And SMT, where we want to do it in volume, because we want to be the Costco of light sources. So we're not sort of maybe Thor Labs or something like this. We don't want to do onesie twosies. We want to sell this to the point where it's a commodity. So it's quite a difficult process today, but we're learning continuously to the point where we're about to release this now in volume. A lot of different characteristics here. You can see 150, 80, depending on the color. So these are big, big numbers. Why? Because the waveguides today are highly inefficient compared to where they're going. So we have to sort of take the heavier load today as a laser guy. So we're putting out a lot at the start because they're going to need it with their inefficiencies today. But as they rise in efficiency, we can drop this down. So we overall we're going to save power, which is a smaller battery, which is all they wear. So everything's interconnected. So today, this is what we're doing. Some people in the audience might be doing this other stuff, which is basically retina scanning, or scanning into the back of the pupil. And these are laser powers are 1 to 5 milliwatts. This is something that Azram also does. It's all about resonators, cavity lengths, that sort of stuff. If you have the recipe, you basically just change different parts of it, put it through the reactor, and you can get very, very low power. But the majority of people, this is where we are, from 10 to 100 milliwatt. This is where we are. So where does that mean in relation to what I just said before? When I said on the side of this LED we had 1 watt and we came out with 350 to 3,500 nits. This here is a laser system. The only difference here, and this is why it's hard to do apples to apples, if this was an LED, we turn it on, all the colors, all the light goes into an LCOS panel. You turn everything on. So that's how I can start off with 1 watt and then depreciate all the way till I get to what sort of hits the eye. Well, when you're doing scanning with this nice word here from our partners in ST, they're basically painting pixels. So they're not illuminating the whole screen. So it's quite difficult for us to say, well, we start off with this power, because you're not actually starting off with all that power. So what we did was we figured out, well, let's just do a D65 white point. We're going to turn everything on and have a white screen. And that at least will give us a measurement point. So if you look at this, I think it's repeated in 2 pages from now. Basically, if we put in 0.8 of a watt of power, we can get out 1,500. And this here is a 60% drop, but it's a lot more efficient in a lot of different ways. So we can show it here, I think. Excuse me. Yeah, the target white point was D65. So this is here where we're mixing. So you can see a big chunk of red. And basically, the blue is half of the green. And then here's the milliwatts in terms of output. And if I do it here, yeah, it's 0.8 of a watt we start, and we can get 1,500 watts, or 1,500 nits. Again, a lot of optimization is happening. But today, these are quite acceptable numbers to start putting products into the market. So when I talked about our laser project, we call it the Vegaless. If I click on this, I think yesterday our partner, Berhat from ST, had his presentation, and he mentioned this also. So this is the glasses. If you go to Displex, they're just inside the door here. You can see they have this pair of glasses. If you see ST, they're at the other side of the Laser Alliance booth. They have the same pair of glasses. And if you come to Azram, we'll direct you to either one of these guys. And you can see these glasses for real. SOP planned for mid-22 for our product. Today we're in engineering volume sampling. And that hopefully is my presentation. Any questions? I know it's late in the day. Oh, sorry. You're supposed to say that.
No worries, Carl. So thank you, Carl. Any questions from the audience? No one yet, so yeah, okay.
So you talked about some of the disadvantages of the other systems. Will these systems, because they're simpler, also be more durable? But as far as like not as easily going out of calibration if they get bumped or dropped or such.
It's a good question. I'm not a system architect. Maybe actually I'll defer to my colleague here. Yeah. What would you think? I would think if you're talking today, because of our experience with LEDs, the LED systems are more robust because they're just more mature. And that is, you do 100,000 hours of something, you tend to know it a bit better than something that's, done a bit of extrapolation. Yeah? So when you ship to 50 million a month of something for 8-9 years, you tend to have a better, org chart or plot chart of where you're going to, and because you're obviously hitting revenue on it, you can then retool and continuously improve, and you can get feedback from users like yourselves. Yeah? So I think if you ask me, need to put a finger in the air, I would say LED today would be a bit more robust. But then again, it all depends on who's the LCOS panel maker. If I look at the laser side, I look at the partners like Displex, so their waveguides are absolutely bulletproof. So there's a complete trade-off. But if you needed me to stick on it, I'd say probably LED, and the reason being because we've just had more time with it. Is that okay?
Okay. Other question? Yeah. So
that's it. Was my presentation so amazing that you have no question? Oh, come on, guys. Okay, I'll ask a question. No. I'll ask a question for you guys because it's supposed to be interactive. Well, give us a straw poll, is that what it called? If you're designers, which I think some of you are, or you're also interested in the industry, where do you see, are you going to be designing in the future? Will it be LED? Will it be laser? Will it be micro LED? Where's your opinion going today? Interactive. Shout something out. All right, I think it's, was it happy hours at the playground now? Yeah.
Yeah,
okay.
After party started at 8, so we have 4 more hours.
Are you suggesting you're going to be doing micro LED?
Someone took the bait. Yes, there you go. No, I'm just saying that when I look at the internet and listen to the buzzwords, these are the competing technologies that we see in the forefront. Yeah? Oh, now we got another question. Excellent.
Yeah, another question. What is using double RGB sources for the megawatt? So this is just single RGB. Do you plan to do it also with double RGB?
Today, yes, we are releasing a product to the market with a single red, green, blue, and because this is what the market is looking for. But as people get to play and use these, there's, how would I put it nicely, looking at shortfalls. And if we had a bit more green, because you've seen that's what happened with our LED strategy. We did red, green, blue, and then people needed so much green. We actually have a separate green chip, a native green we call it. Yeah? So we may see that happening in the future where you'd have an OR GGB laser. And the good thing is we can do that. Yeah? And we can have a separate chip in there, or we can do it a dual channel, things like this. So is it on the horizon? Possibly. What I need is, that's why we're here today, is feedback from you guys. So if you're telling us that there's not enough green in that D65 mix, or you're really hitting it hard when you're dropping it onto the waveguide, yeah, sure, we can put in more color if you want. Or we can raise the existing power, or we can maybe widen the bandwidth of the actual green that we're putting in today. So these are things that we need feedback from you guys. Does that answer your question?
Yeah, that answers.
Cool.
I was more looking for you can laser beam scanning that you can double the resolution. So that was maybe the background of my question.
Oh, maybe you can share that with everyone here then, because doubling the resolution is probably something that a lot of designers are looking for.
So I have a question about some of the potential artifacts associated with laser sources. One of the concerns with the HoloLens, the latest product, is that there are artifacts based on the lasers with the waveguides. And I'm wondering about the relative merits of LED. The problem with LED, of course, is the étendue of these devices. But what is the kind of trade-off between the two camps? in terms of the waveguide architectures. Maybe this is a question for you too, Joe.
Let's give Carl try first.
Okay, 30 seconds. So the Microsoft guys said, so let's put a finger in the air and here's a product. And it was LEDs, probably someone who's familiar with LEDs, and an LCOS panel. And it worked, it was great. It was a tech demonstrator. Then they went and made this really amazing thing with lasers, and it was awesome. And Carl Guttag, et cetera, will pan it till the cows come home, which is good. Because it was 2016. That's when that thing was designed. It's got a crappy field of view, it's got artifacts, it's got everything that should be there in 2016. But if you look at the development that's happened, I mean, were you guys even around in 2016? Barely, yeah, there you go, yeah. He was just still in high school. So the idea is you go from there to 2021, there's a lot of development. There's this laser alliance. There's people meeting on a weekly basis trying to get over a lot of this artifacts. There's fringing, there's speckle. There's a lot of things wrong that have been put right. And people are getting serious about it. And the big guys and small guys, if you look at MEMS, there's yourselves, Augmented, a small guy, and then ST, a big guy. And we're all working together to move the paradigm. So I think 2016 is when you see HoloLens 2 laser. So it's not really fair to say that is what lasers are today. So now if you want to answer the waveguide section.
Yeah, maybe. To just add that, of course, you are welcome to listen our panel discussion tomorrow, touching these topics. Meet us on our display booth. So I guess my responsibility here is not to get into details on the waveguide side. Any other questions for Carl, Azram, and lasers, LEDs? Okay, a few questions here.
By the way, nice presentation.
Oh, thank you.
Maybe this is a pretty simple question, but where do you see your existence long term? When micro LEDs become mature, is there still going to be a place for laser at all?
Yes, yes, and yes. Our opinion is that LEDs are today going to get a lot better in where they are because people are interested, because now there's use cases. Yeah? People are using glasses to do playthings, or not just enterprise. So you saw our new Mosaic. It's going to make the same experience enterprise, but it's going to look a heck of a lot better. So maybe we're not having millions of people, but it's not only going to be guys in nuclear power stations. Maybe the AT&T guy on the pole or the PG&E guy will have these sort of sets on. So it might be a few million pieces. Still not going to shake the world. So LEDs will then go to mini LEDs per se, and then at the same time, 2025, 26, 27, you all read the Yole report, same as me, that micro LEDs will come. And we're excited because the more people wear headsets, the better it is for everyone. It's such a big revolution. The rising tide, we believe, will take all ships. And it's, if you look at the problems these guys have, I mean, red is just an absolute killer. You had the GaN for blue and green, yeah, it's pretty much there. But then you got to do monolithic. And you saw the Facebook guys, they spend billions a year, and the only thing they did was put a camera on there because everyone's so scared of putting technology on your face. So it's going to be a long run. And I think this is shared by a lot of people. There's room for micro LED, there's room for laser, and there's room for even LED. It won't go away. And this is not a VHS versus Betamax. Yeah, I'm showing my age. A lot of kids are like, what? So the idea, it's not a one or the other. We believe that there is room in this, the global ecosystem of it for all these technologies to survive. And the thing is, we talk about lasers, we're talking about the HoloLens from 2016. With the Laser Alliance, we're getting a lot better, a lot of different things, and we're still very young. We're not going to wait for micro LED to sort of come and eat our lunch. We're going to be a good competitor, and we'll probably pave the way for them in a lot of ways where, users and designers are like, lasers are awesome, but they just can't do this. And that's a great space possibly for micro LEDs and vice versa. So we welcome the challenge of having another technology because it's only going to make us better. And and vice versa, because they're not going to be the only game in town. So we believe that there will be room for all of us. So the more out there, the better. Does that answer your question?
Yeah, that was an answer.
And there was one more. All right, let's thank Carl again.
All right, thank you.